Hello students, welcome back. We completed up to section 3 of this notebook. Now let's move on to section 4, Contingency Table. This topic is a kind of tweener. Partly it belongs to chapter 3. Did I say chapter 3? Excuse me, module 3. And partly it belongs to module 4. And the majority belongs to module 4, probability, especially for conditional probability. So please consider this part as a preview of what's to come. Okay, here is the original data set we considered in section 1. We have a bunch of names and two qualitative variables, gender, male and female, and major, liberal art, business administration, and technology. Remember? And one way to represent the same thing is to use this kind of table. Contingency table or cross tabulation. Now we have male and female, which go in rows, and then majors, liberal art, business, and technology, which go columns. And this contingency table shows something called marginal distribution. That is the proportions separated by rows and columns like this. So what do we have here? Total is 30, so that's 100%. And then there are 18 men and 12 women in this group, so 60% and 40% distribution. And as for major, 11, 10, and 9 students, so 37%, liberal art 33%, business 30%, technology, and so on and so forth. And then, for example, 6 male business students out of total 30, so that's 20%. And then 2 female technology students out of total 30, so 7%, and so on and so forth. All these numbers are based upon the denominator of 30. Now, these tables, let me keep this on. Now, these tables show conditional distribution or conditional proportion. And this time, let's consider men only and women only. Okay? So just consider men only and do not consider women at all. So let me see. No. Yeah, okay. Over here, that total 18 men. So we are looking at just the condition of men only. Then under that condition, the total is 18, not 30. So the proportion of liberal art major for men is gonna be liberal art major men only is gonna be, let's see, 5/18. Does it make sense? So for liberal art, for the entire group is 11 out of 30. But if you take a condition and men only, then it's gonna be 5 out of 18. So proportion of liberal art. I used liberal art before, so let me use something else. Business. And this time women only. So this time total is 12. So we are not considering men at all, just women only. So 12 is total. So how many business majors are there? There are only 4 because we are not considering men at all under the new condition. So this is going to be 4 out of 12. and that's going to be 33%. Previously, that was 5 or 18, 28% approximately speaking. So these kind of things are called conditional proportion. And these bar charts show conditional proportion for males, females separately. Two different conditions. Here's another conditional proportion, this time based upon major. So let's not look at this. Look at this table and then the major. Okay, this time let's not consider business or technology. Just look at liberal art majors only. So total is now 11. And these, just throw those away. Just total is 11 this time. And then what is the proportion of female on the liberal art majors only? So total is 11. And then how many female students are there? There's 6 out of 11. And that is 55%. Make sense? So basically we are changing the denominator. And that's called conditional proportion or conditional distribution, because it's coming from new condition. A new condition for men only, women only, or a new condition of business majors only, technology majors only. So those kind of things are called, those kind of aspects are embedded in contingency table and cross tabulation. Sorry, no more problems or exercise problems here associated to this. They're all dumped over to the next lesson, lesson 4, probability, and these will be revisited in a new name of conditional probability. So that's where I'm gonna stop, and so much for section 3. So much for section 4 of this notebook.